You've probably seen it, right? A brand new, super expensive piece of machinery fails spectacularly, while some old, clunky thing from decades ago just keeps on working. It's a classic mystery in the world of engineering, and it's exactly what we're going to unpack today. So, what's the deal here? Why do some of these huge, costly projects just fall flat, while others become absolute legends of reliability? Is it just random, a roll of the dice? Or is there something else going on? A secret ingredient that separates the wins from the total disasters? Well, here's the thing. It has absolutely nothing to do with luck. The secret is all about a disciplined, strategic approach. Success or failure isn't decided on launch day. It's baked in way, way back in the initial design and acquisition phase. It's all about designing for success from the very first minute. Okay, let's get into it. We're going to break this strategic toolkit down into three main parts. First up, the foresight and planning tools. You can think of these as our crystal ball. They're all about helping us look into the future and stop problems before they even get a chance to happen. Now, I know that's a list of some pretty technical sounding stuff. We've got things like lifecycle cost analysis, FMECA, and reliability-centered maintenance, but stick with me, don't worry about the acronyms, we're going to make this super simple. So let's kick things off with lifecycle cost analysis. It's so easy to get fixated on that initial price tag, right? But that's just the tip of the iceberg. Think about buying a car. The real cost isn't what you pay the dealer. It's the gas, the insurance, all the maintenance, the repairs, and eventually what it costs you to get rid of it. That entire amount, from cradle to grave, is the lifecycle cost. And designing for success means looking at that whole picture from the start. Okay, next up, FMECA. Now, for this one, you basically have to become a professional pessimist. I'm serious. You get your team in a room and you brainstorm every single thing that could possibly break. A seal could leak, the software could glitch, a weld could be weak. Then you figure out just how bad it would be if that failure actually happened. The magic here is that by finding these weak spots on paper, you can fix them before they become really expensive or even catastrophic problems in the real world. And that flows perfectly into our next tool, RCM, or Reliability-Centered Maintenance. RCM basically takes that what could go wrong question from FMEA and asks the next logical thing. Okay, so what's the smartest, most efficient way to stop it from happening? It's a really logical process. First, you figure out what the system absolutely has to do. Then you look at how it might fail and what happens if it does. And only then do you pick the right maintenance strategy. It's about being strategic, not just, doing maintenance because the manual told you to. So let's just boil this down, right? Each of these foresight tools is designed to answer one big, important question. This slide lays it out perfectly. Life cycle cost asks, what's the true total cost? FMECA asks, what could go wrong and how bad would it be? And RCM asks, what's the smartest way to prevent it? You put them all together, and you get this incredibly clear picture of the future. All right, so once you've peered into the future with your foresight tools, it's time to actually draw up the plan. So let's move on to Section 2, the blueprint and foundation tools. This is all about laying a rock-solid foundation with really clear standards and strong partnerships. And this part of the toolkit really comes down to three key things: having crystal clear specifications, embracing standardization wherever you can, and, this one's huge, properly qualifying your vendors. They might sound kind of basic, but believe me, getting these right is absolutely mission critical.
Let's talk about specifications for a second. Think about them like a super detailed recipe for a cake. A good recipe doesn't just say mix some stuff and bake it. No, it gives you exact measurements, precise temperatures, specific times. It's exactly the same here. A good specification document covers the whole shebang: performance, reliability, and even details for the people who have to use it. Without that detailed recipe, you're just guessing, and you can't guarantee a good result.
Now, a really powerful tool in your blueprint is standardization. Look, customization is awesome when you have a truly unique problem, but for most things, standardization is your best friend. Just imagine a hospital where every single IV pump is a different make and model. The nightmare. You'd need a giant warehouse for spare parts and special training for every single one. By standardizing on just one model, you make maintenance way simpler, you slash costs, and you actually improve patient safety. It's all about creating an efficient, interchangeable system that just works. And this brings us to a really critical point, summed up perfectly right here. You can have the best, most brilliant design in the entire world, but if the parts you buy or the partners you work with aren't up to scratch, your whole project is basically doomed from the start. Qualifying your vendors isn't about chasing the lowest price. It's about making sure they can deliver the quality and reliability your blueprint demands.
Okay, so you've done your homework, you've got the blueprint. Now for the fun part, actually building the thing. And that brings us to our third section, the flawless execution tools. This is all about turning that brilliant plan into a brilliant reality.
In this phase, it all comes down to two key things: absolute precision during the initial setup and startup, and then a really intelligent, engineered maintenance strategy for the long run. This is one of those things that is so important but often gets overlooked. Remember this, it's not just what you build, but how you build it. A tiny misalignment during installation, one little misstep during the startup process, that can create a hidden flaw, a ticking time bomb that might not go off for months or even years. Precision installation is all about giving your new asset a perfect, clean start to its life.
And once it's up and running, hey, the job's not done. A truly modern, engineered maintenance strategy is built on 4 key components. And this chart here lays out that philosophy beautifully. Look at this. The biggest piece of the pie, a full 40%, is condition monitoring. That's using sensors and data to literally listen to the health of the machine in real time. Then you've got about 30% for your traditional preventative stuff. After that, you've got autonomous maintenance, which is empowering the operators to do daily checks, and a smart spare parts strategy. See? It's a balanced, data-driven approach. It's not just guesswork.
Okay, let's bring it all home in our final section, the complete system for success, because the real magic here isn't in any single tool, it's in how they all connect and work together to make each other stronger. So, do you see how this all clicks together now? It's not just a checklist of things to do, it's a powerful loop. The foresight you get from your analysis at the beginning, that dictates the reliability targets in your blueprint. That super detailed blueprint then gives your installation team the exact standards they need for a flawless execution. And guess what? The data you get from that execution feeds right back into your next round of foresight. Each phase strengthens the others. It's a complete system for building things that are truly, genuinely designed to last. And that just leaves us with one final thought to chew on. We've talked about all of this in the context of engineering and machines. But what if we applied this same design for success mindset more broadly to software projects, to new business strategies, maybe even to our own personal goals? Just imagine what we could achieve if we always started by designing for success right from day one. Something to think about. Thanks for tuning in.